each of these different, these are not topics, each of these different knowledge, knowledge bank, I would say, right? So data science, machine learning, and artificial intelligence are knowledge bank in themselves. So it's important. We need to understand the building blocks. So here we are. I'll start with a quote. A senior VP at Gartner, IDC, McKinsey, Deloitte, all of these companies are the ones who do a lot of research, especially when it comes to. Right? Any questions? No. Okay. Especially when it comes to the recent trends, the following trend, the trend that gets built, right? So you also look at the hype curve, right? So Gartner, IDC, they come out with a lot of these sneak peek into the future, right? Yeah, Manish, there is no attendance as such, right? So attendance is not captured. This is for section B. Yes, you're right. Yeah, you can attend any of the sessions. You can, in fact, what I would suggest is you attend both the sessions, if time permits, because you get a different perspective. And even if you don't get time to attend the live session, I would suggest and I would recommend strongly that you at least listen to or go through the recording. If you missed it on Saturday, attend on Sunday. If you missed it on Sunday, attend on Saturday. And whichever you missed, I think it is always good to go through it, because while we talk about data, I can talk from my perspective. I can talk from my point of view. Partha will talk from his point of view. While we still focus on data science, data management, machine learning, and artificial intelligence, more the merrier. Right, so that's what it is, and you folks have been lucky to have faculty async learning opportunity and 2 live sessions. So I would want you to make the best of it. All right. Yes. Attending the session is not that very sacrosanct for the sections. It's only that when you're submitting your assignments, just look through the deadlines. I don't think the deadlines are different, but just in case, and ensure that you are submitting it on time as per the deadline. That's it. Nothing else. You don't have to worry about it. All right. Yes. So look at what he has to say. Information is the oil of the 21st century, and analytics is the combustion engine. Well, combustion engine is on its way out, with the EV shaping up. But still, this is a good parlance. This is a good correlation that we can bring in, right? So we have been hearing that data is the new oil, data is the new fuel, but it's not data, it's information, how we use the information, right? So it's a journey that we start with the data. We convert the data to information. From information, we look at insights and building our knowledge and then the wisdom. So if we have to go through all of this, we need to understand the nuances and the interconnection, the relationship, the correlation between each of these different processes. So information is what is driving businesses these days. And that is what we refer to as data-driven decision-making, DDDM. Data-driven business decision-making, data analysis-driven business decision-making, and data analytics-driven business decision-making. So we are talking about the fuel and the engine, right? So that is where I think data and information are being the prime movers of any industry that we talk about. It's no longer the brick and mortar companies that would function the way they would function probably in industry 1.0, 2.0 era, or even, for example, industry 3.0 era. We are in a cyber physical interface era wherein we are in a connected world. Every one of us are connected. And every one of us, every one of the things that is connected is generating data, fueling the information, which is what needs to be understood for using it for building businesses. Recalibrating and reshaping older brick and mortar businesses through data driven digital transformation enabled organizations. Two, the digital native companies, which are built on using digital technologies, digital transformation, and using data transformation for driving their business, for growing their business. It's also a way of looking at how information is fueling innovation. The access to information has become ubiquitous. The access to information has got democratized. I'll give you an example. 20 years back, if somebody comes at our home, our friend, family, friends, or relatives, we would want to boost off the knowledge our children would have, right? So we would say, "Are beta, come here, tell uncle the 7 wonders of the world," right? 7 wonders of the world, 14 wonders of the world, and all of it. Wow, list. Okay. So 20 years back, the child, maybe we have also gone through all this, the child would have told about the 7 wonders of the world, and he or she would have been considered as an intelligent child. But today, that intelligence is no longer intelligence, it's just information. The World Wide Web, the internet, has made the intelligence of yesteryears to just a piece of information today. And while we talk about that, we are also talking about information being the oil in the 21st century. So we need to understand the exact meaning of what information meant a few years back and what information means today. So that's where the correlation comes in about data, information, insights, knowledge, and wisdom. And if we have to traverse that path, we have to look at data analysis and data analytics. We need to understand the difference between each of it. Right? So we will go through all of this. We will explore everything in our own way. And I extend it of not saying just data or information is the new oil or the new fuel. It's the new water, it's the new air that we breathe. It's the new water that we drink. It has become so very important. It has become the most important utility that one needs to understand. Not just understand, one needs to handle, one needs to manage, and one needs to use it for your own advantage. So what is it? Basically, this is what I've been talking about, right? So it's the new fuel which is helping in decision support and being used across various different industries, various different sectors, various different segments. And we look at the KDD process, the knowledge discovery of data, to go deep. And what are we going deep for? Where are we going deep? We're going deep into understanding what the data is all about. What does the data speak? What is the data telling me? Right? And why has it become so important? Why are we talking about data so much? Is because today we don't have the dearth of data. Today, it's a problem of plenty. A few years back, a decade back, we didn't have systems that would help us build the data or collect the data, for example. But today, we have systems, we have applications that don't need to worry about data. Data gets generated automatically. It's an automation of data generation, data collation, data collection, and data consumption that has led to the vast expanse of availability of data. And this is what we refer to as big data today. So to understand big data, we need to dig deep. And that is where the KDD process is what will help us in knowing more about the data and using the data to our advantage. So it's all about processing the data. So by now you would have understood that we have been talking about data and information and transformation for bringing in innovation. It seems to be madness, right? So absolutely, it is madness. Today I'm dealing with uh, the challenges of handling humongous amount of data that is being generated as we speak, for which, while we have the technology, it's about how we use the technology and how we bring about the meaning behind what we are doing. So it is like putting method to the madness to actually make sense of all this data that comes to us. And not all of the data is useful. Please mind you, right? Please make a note of that. The data that comes to us is data. Not everything is useful to me. So keeping that in mind, we need to bring about the right way of handling the data. So we will go through this journey. Today is just an introduction. So we're talking a little bit high level and also getting to the building blocks, the smaller building blocks, which would be needed to converge and bring about a big picture for all of us to understand. Right.
Atul,
So yes, please.
when you say selection, pre-processing, and transformation, I guess you will also agree that one of the most important thing is cleaning data, right? We get plenty of data, but sometimes it can't be useful, and cleaning data takes a large amount of time.
Absolutely.
So, since you are from industry and you have worked in industry for plenty of time and well seasoned, I guess. So, are there any systems developed by companies to make sure that they get clean data, or at least the amount of time that we spend on cleaning data and making it useful? Are there any systems that are being developed by any companies?
Oh yes, a lot of it. Uh, each each organization would have its own way of dealing with it. But the basic tenet on which it would have been built is what we are basically talking about, the KDD process, right? So mainly when you're talking about cleaning up the data, it is this pre-processing where we end up spending a lot of our time, right? So it's a function of the size of the data, the quality of the data, the characteristics of the data, and the usefulness of data, right? Rightly pointed out by you. So, is there a way that I can get clean data? No, I will not be able to do that, and that is not what I would want to either, because I want all the data. Only when data comes to me, I will decide what part of the data, which part of the data is useful to me. Right? A simple example is that you would want to test the waters for a new product that you're launching in the market, right? So while your marketing team would have done extensive market research, competitive analysis, competitive landscape, consumer feedback, it's important for you to also do a little bit of it's called an A/B testing, right? Wherein I would expose the features and functionalities of the new product intentionally onto a few social media platforms to get some feedback, right? So I want that data as well. So various ways in which I would want to collect the data, various ways in which the already collected data needs to be consolidated. And when we talk about raw data, it is about sourcing it from various different sources. And when I'm sourcing it from different sources, it may not come to you in the right format. When I say right format, it comes to you in different formats, different forms, different formats, different size, different shape, right? So that is the challenge, wherein I don't have a control on. Whereas once I know the sources, I know what is to be done, which is what we are talking about. And this can definitely be made more robust and efficient ways by bringing in the right ways of using the right technological tools, techniques for handling the data, processing the data, transforming the data, so on and so forth. Right. So we call it as data engineering. I will talk about it going forward a little bit after we have set the base.
Sure.
Right.
Thank you,
Yeah,
Atul.
yeah. Good, good, good. Is KDD a standard term? Yeah, this is when we talk about data, there are multiple different terms, terminologies, and jargons that come in. KDD has been there for quite some time now. We refer to it as and when need be, especially when we talk about data mining and data processing and data science as well. Right? Yes, usefulness of data would vary from company to company. Yes, correct. We spoke about it, right? Correct. Yes, not just company to company, project to project, business challenges that you're solving, right? So various different aspects and various different factors that come in. So it's easier said than done, and that's where we need something to fall back on. And what better way to fall back on than to have a process, tried, tested, and trusted process that I can refer to at least, right? Not necessarily I'll have to go through the defined process. I can mix and match my experience, my expertise to the various different processes that have been defined as a industry or as a industry standard or a company standard. But ultimately, it would fall in any of these processes that we are talking about. It could be KDD, it could be CRISP DM, it could be OSCMN for data mining and data science. All right. So anything difference between data digitization, digitalization? Oh yeah. Of course. These are interchangeable. As you are saying, you're right. Okay. So can someone share? Okay. Does rich data like images file considered as data in KDD terminologies? Anything and everything is data, whether it is text in a structured format or text in an unstructured format. The audio files, the video files, the images, the animations, the AI generated data across, right? Everything is considered to be data. Today, everything is data. Anything and everything is data. The recording that you would watch after this of the Zoom recording is data. The transcript that you would get out of the entire session, which would come to you as a text file, is data, right? So Zoom also gives you not just the video, but also the audio file. If you want only the audio file, you have that availability as well. Of course, we're not sharing the audio file. We're just sharing the complete recording. If you want to explore, Zoom has all of these features in the backend. So multiple data sources, multiple data types, multiple data forms and formats that come to you, right? Like air quality index, data quality as well is important. How do we look at data quality and trust the process? Yeah, we'll get to it. We'll get to it. All right, good that you're bringing this up. So this is what is going to define or maybe redefine the way industries are looking at using the data, right? Do we later come to know the various data processing tools, techniques, effort, cost? We will have all of that covered. Yes, it's a long journey. This is just the first step. All right, that we're taking. So let's talk about data in the first place then, right? So let's understand data. Uh, it's oil, and you just said data needs to be refined, right? This is where we talk about processing, pre-processing, cleaning, cleansing, all of these terminologies that we use. Uh, but the best technical terminology to use for refining the data, cleaning up the data, uh, scrubbing the data would be data wrangling, right? So unless and until I don't clean up the data, it's of no use to me. It is like otherwise it's gigo, right? Garbage in, garbage out. So definitely I have to look at how I can clean it up. Uh, Data is an infinite resource today, wherein user generated content, UGC, is what is expanding and exploding as we speak, as I told you, right? So we are all on social media platforms. We interact, we post, we like, we repost, we put in our thoughts, we put in our comments, right? So all of this is data, and through the data, I can figure out what your preferences are, what your likings are, what is your personality like. Yeah. So uh, all of these various different multidisciplinary science has been applied in the back end for various different use cases, for understanding consumer behavior, for understanding purchase pattern, for understanding the preferences, for understanding the perceptions that get created, for understanding the psychology of different sets of people, different groups of people, different personas. So the way it all steams up, or the way it all lines up, is that we are moving away from just customization to personalization. It is hyper personalization today, right? And hyper personalization is possible only when I know you really well. It is like the elders in the joint family a couple of decades back would know the likings and dislikings of everyone in the family, right? It was so easy for them. But today, it's not easy for various different reasons. And now that I have data, companies are relying on this data for bringing in the much needed understanding of the market, of the reactions from the market, the perceptions, the preferences, right, the likings, the dislikings, so on and so forth. All right, yeah. So that is where we say data is everywhere. But data everywhere, not a drop of data for everyone to look at. Yeah, so that's where data engineers, data architects, data analysts, business analysts, data scientists, all are working towards ensuring that it's not just the data, but it's the information through the data, it's the insight from the data is provided to the right people in the industry, in the research and development organization, in an institution, uh, uh, even for your personal use, right? So all of this is being made available for you to take the right decisions. All right, yes. So look at it. You could extract data, but then you should think twice about how you use it. And why am I saying this? Is because uh, the way you will use the same data and the way I will use the same data would be different. Now, that is where some standardization would be needed. And to bring about that standardization, I need to ensure that I have the processes in place. I have a standard operating procedures in place. And that's where we talk about the DevOps, the ML ops, the data ops, and the AI ops today, right? So it all converges to the operations. And operations is all about how I apply the various different constructs of project management, data handling, machine learning development, data management, and AI ops, right? So it is DevOps, data ops, ML ops, and AI ops that one needs to understand in its entirety, right? So that's how we need to look at it. Okay, so in today's AI world, we are struggling to distinguish between, yeah, oh yeah, a lot of it, lot of it. We're going to cover this, right? So the deep fake is on the rise. While that is on the rise, the ways and means, the tools, techniques, and technology to identify AI generated data, especially fake data, is also available to all of us. That's a good question. So very good. As the raw data is often unstructured, a lot of information, noise in the data. Yeah, we do have a lot of these tools and techniques, and that is what we're going to learn, right? Yes, we all know this, right? So we have to clean it up. Data required is actually defined by user requirements. Should the filter start from there? Yes, it starts from the business need. You're right. So unless and until I don't know what the business needs are, I should not be looking at the data in the first place. Only after I understand what the business needs are, what the business challenges are, you will know what you are getting into. And that's where you will know exactly what data points, the variables, and all other aspects that define the project will help you to actually solve the business problem. You're right, right? So we have seen all these various different dashboards and graphical representation of data, right? This is the end thing. This is the new thing that every organization wants to look at data. And it's not data in its raw format, it's data in its processed format. It's the data and the information being presented in a way that even a layman would understand. And what better way than to provide it in a visual manner, right? So that's the journey that we're going to traverse, right? So stay put. It's a long journey. It's an exciting journey. It will bring in a lot of interesting stuff out of every one of us. All right. So while we have some points on the chat, I wanted to bring this up, right? So data never sleeps. Yes, thanks to all these platforms which are auto generating data, which are getting folks to be a part of this data revolution, from ChatGPT to Amazons of the world, to all the social media and digital media platforms of the world. Look at what's happening, right? So the amount of interaction that's happening, the amount of uh, communication that's happening is unprecedented. So I'll share this link. Keep a look at it. They keep coming up with a lot of information, right? Information, data, which sometimes is really mind-boggling. Yes. So as raw data, often that is done. Data required is actually defined. That's done. While collecting data and data points, should there be an initial filter based on its classification, like PI data, research data, etc.? That is something that you will need to define, or you will need to identify. If you are collecting it afresh, you will have a way or a controlled mechanism as to how you will go about doing it. But that's not the case all the time. I have ready data with me, which is coming to me from various different sources like this, right? So I would not have the choice to define that. So that's where I will have to see, uh, or I will have to use the right tools and techniques and technology to bring about a meaning from the data, which is meaningful and which can be impactful for the business problem that I'm trying to solve. All right. Yes. So let's get going. So ultimately, it's all about creating value, right? So business value. So using data, how do I do that? It's very simple. It starts with what you're supposed to do, aligning with the business strategy, aligning to what the business goals, business uh, vision, mission, objectives, all of it. So if that's the case, then it's all about bringing in all of the components that drive a business. And basically, it will fall into the PPT model. Okay, what is PPT? No, not the PowerPoint presentation. PPT is basically the people, process, and technology. So business strategies are driven by people, process, and technology. People are the ones who will use the technology, and technology is the one that will help me access the data, convert it to information, bring about the insights, and then suggest actions that will help me build business value. So while these are some building blocks, right, very important, and for all you know, when we talk about data transformation leading to digital transformation, leading to bringing in new age solutions through machine learning and artificial intelligence, it's all about how people use the data driven by the right processes and enabled by technology. So technology is using the data for the business, wherein I do a lot of data and analytics strategy built around by using business strategy and people and processes coming together. And all of this is going to help me in building business value, right? So uh, let's talk about digitalization, and digital transformation. Digitization is nothing else but converting the physical data into digital or electronic or basically electronic data, right? Electronic data or digital data. Digitalization is the process that we deploy for ensuring that the digitization goes through in a proper way, and I handle the data through the data management constructs. And digital transformation is all about how I make use of the data by applying the right tools, techniques, and technology for data analysis and data analytics. So, digital transformation is accessing the data that is available to me through the process of digitization by applying digitalization processes so that I will be effectively analyzing the data, which is data analysis, and moving forward, I will apply data analytics as well so that it helps me in building predictive models. So that's the journey. I've been talking about journey a lot, but that's how it is, right? So now you know why I said that a couple of decades back, we were all busy in building systems that would help build digital transformation systems. We've been talking about data ever since, I think, time immemorial. But the way data was captured, the way data was stored, or the data was preserved for thousands of years was different, and it's different today. So converting the age-old data, right, uh, data from the Nalanda University times, for example, if you have to go to something about past, converting that data into something that will be useful today is a process that I would look through of digitalization, and digital transformation. And now that I have all of this data in a digital format, what is it that I will do with the data is that I will go deep into it for bringing in insights, for bringing in actionable insights so that it will bring value to my understanding, my knowledge, which would be the same thing for the businesses. All right. Yes. Hopefully your questions have been answered. Anything else on the chat? No. Okay. So and this journey, while it looks to be uh, easy, as I said, it's easier said than done. Every time you get a new business challenge, a new project, it's a challenge in itself. Because one size fits all doesn't work. It has never worked. It will never work. So I will have to fall back on some process. for which we will talk about the KDD and OSCMN and CRISP DM and the data science lifecycle processes, DevOps, data ops, ML ops, and AI ops processes. And then it's left to you as to how you would use it in the best possible way, keeping in mind the context that you're working on, keeping in mind the situation and circumstances that you would be working on for solving business problems. All right. What is this? Melvin Jose. Who's Melvin Jose? Melvin. Okay. Why is this?
So
Requested you to stop AI companion.
It's a typo error. Sorry.
Typo, right? Okay. So decline. Okay. Yeah. That was by mistake, right? Yeah. It happened. No worries. If I'd done that, you would probably not get the meeting summary, right? So
yes,
by mistake, that's perfectly fine, not a problem. So no, it's a good point. Good that this popped up. What's happening is in the back end, while this recording is happening, there is a system that is trying to create a summary of what all I've been talking about. Right. So the use of technology, the data that Zoom is taking in here is my speech, right? I'm not giving a speech, of course, but in this parlance, it is speech and converting the speech to text. And it's not just converting everything that I'm talking about. It's using the transcript to even summarize, right? So it comes to you as a notes summary of what we have covered. So you just look at the headlines and you would correlate it with the notes that you are making, and hopefully I'm presuming you are creating some notes, at least some points, right? It's a good habit. While you're going through these sessions, it's easier understandable. But unless and until you don't make your own notes, and when I say make your own notes, it's not about typing it, it's about writing it, right? So write these points in your own words. That will help you in correlating to what we have spoken here, and it will help you while you recollect whenever you would be submitting your assignments. And that's how you will enhance your understanding, enhance your knowledge, and enhance your capacity to apply it when you are faced with these business challenges, right? So I would encourage that. Okay, so thanks for the intervention, even though by mistake. That's perfectly fine. You know the implication of it and the importance of what we are doing. Okay, wonderful, good.
Thank you.
Cool, no worries. Kumar says, with so much of data being captured and much more to capture in coming years, how do we maintain the recentness in data? Wow. Okay, so this is where we will talk about the quality of data, right? It's not just about the accuracy, it's not just about the consistency, it's also about the relevancy of the data. Wonderful point that you brought out. Now, for example, I'm just picking up a name. Okay, I'm a Tata fan. So of late, Tata is launching, Tata and Mahindra, of course, are launching real good consumer segment vehicles, right? So some good designs, some good technology, new technology combined with old technology is being used, and newer models are being introduced into the market. How do they know whether the product that they are launching would be a success or not? Right? So they would come out with some teasers, and then it's all about getting the feedback from all of you, right? So the more you interact, the more they would know about the likings, the dislikings, and what you like and what you don't like, so that when they actually bring out a product, it would be acceptable to a larger mass. So by this, they're not only engaging with you folks, they're not only building up the hype that there's something new that is coming in, it's also about ensuring that they would not fail. So it's a risk management, risk mitigation strategy that these companies use, right? And why do you think there are a lot of these controversies that happen, right? Such controversies were not there a decade back. These days, a lot of controversies, and we get carried away with these controversies. By the way, all of these controversies are created intentionally, especially just before the launch of a new movie, just before the launch of a new product, just before the launch of a new platform, a new service, or whatever it is, right? So it's basically to see the reactions, right? So this is how uh, companies make use of the various different platforms that are already available to me, right? So uh, we will definitely keep looking at how we will build on all of these various different aspects. But yeah, uh, the data quality is paramount, which we will have to focus on, and that is what is the job of data analysts and data scientists. So having said this is the process, right? So data science process. We start with business understanding. Unless and until I don't understand the business, I will not understand the data, because I would not know which data is helpful for the business. While I have a dump of the data, which of the data is relevant, and how do I use it for solving the business problem is important. So while you may see that it is linear in nature, it is sequential in nature, it's actually not. It is iterative in nature. It is a to and fro that would happen from here. Only when I know that the relevant data is being used for solving the business challenges, I would go forward. Right? So we are applying an iterative process at each of these steps to ensure that I am on the right path. And with so much amount of data coming to me, I better be on the right path. Otherwise, there's no point in getting to this stage, which is the modeling stage, without knowing what the business problems are, right? So I would not. So let's get back. Okay, so this will make sense. So now that I know what the business problems that the business is facing, and I also know the availability of the data, internal data, external data, data coming in from the various different applications that are being used by the organization internally, data being generated by all the stakeholders, internal stakeholders and external stakeholders. It could be your suppliers, it could be your vendors, it could be your upstream partners, your downstream partners, your customers, your competitors, all of it, right? So I'm talking about understanding the data from all different angles, all 360-degree. And once I have this data, I will, of course, from here to here, there is a journey in between. We will talk about it as we go forward. There is this process of ETL and ELT and using the data warehouse, using data lake, and all of that would come in. Because where will I store the data? Where will I store this humongous amount of data? Right. So for which I need to have the right ways and means of not only collecting and collating the data, but also consolidating the data, storing the data, so that I will start consuming the data for data preparation. So data preparation, if you see, I'm filtering it out. I'm filtering out a lot of data which is unnecessary. I'm eliminating a lot of data which doesn't fit into the data quality characteristics. I'm going to manage the data. I'm going to transform the data in a way that would help me in building a model for solving the business problems. Right? So it's important to understand what goes in here, and I'm going to talk about it. So we are building it slowly, right? So there's no hurry. All of this needs to sink in. Only then, from week 4 onwards, when it starts galloping, you will be able to keep pace, right? So don't hesitate to ask questions upfront. Later on, it'll definitely be helpful. All right. So questions here. Could you please elaborate modeling? I'm going there. I've still not gone there, so I will talk about it. How easy is it to collect data from different stakeholders? Uh, you're not intentionally collecting data. Data is getting generated invariably, right? So when I'm talking about stakeholders, I'm talking about the emails that they send, the documents that they create, the various different communication that they have, formal, informal, because it is digital in nature. Everything is being monitored and collated and collected and consolidated in the backend. So that becomes my data repository, right? So I use that data and put through the KDD process, the data science process, for establishing the relationship between various different interactions, various different data elements, whether it is internal or external, and start making sense of it, right? So when we talk about insights, it's all about establishing the relationship between various different data elements, data points, and at the same time, it's not just about the relationship, it's about the strength of the relationship also that needs to be understood. And this relationship and the strength of the relationship is what will be useful for solving the business problem. And to know which relationship to use and which relationship not to use gets defined because you understand business really well, right? So this is how everything is interrelated, interconnected. And now that I have good data, minimum amount of data that will help me solve my business problem, I would start building the models. Now, models are nothing else but like a mold, right? So if you have been into what foundry and forging and a little bit of engineering, or not that you have to go through engineering, but you would have seen, right? Uh, uh, how uh, how various different metal parts get created, or how various different plastic items get created. These are all through molds, and molten plastic or molten metal gets into that mold, and once I cool it through the annealing process, the metal or the plastic would take the shape of mold, right? So it's as simple as that. Modeling is like a mold of yesteryears. But the only difference here is that the model here is that of a combination of the data and various different machine learning algorithms that would get applied through the DevOps, the data ops, and the ML ops in this case. We will get to it, but for the time being, modeling is nothing else but a mold, which is a generic mold for the business to use. And the input to the mold would be the data that comes to it. And when the data comes to it, it'll analyze, it'll do all the various different data transformation and apply mathematical models, statistical models onto the data and provide you with some insights, provide you with some predictions, which the business would use. Right? So that's the parlance that I can give. Even if you've not understood for the time being, at least you have understood that what a mold is and how a mold works. We will keep reinforcing this as we go step by step, week by week, module by module. And I know not everybody would be on the same page. Not everybody comes from the same background, same experience, same expertise. So not to worry. Each one of you can understand in your own way, and you take your time. There is no hurry, right? So it's important you get your basics right. As fine. Okay. What is it? Does securing these data is also part of data science? Securing, yeah, that is part of my data engineering part of it, right? So data security, data privacy, all of it is part of the tools and techniques that I would use, tools, techniques, and technology that I would use, which would be facilitated and enabled by a data engineer. Since same data collected can be used for various processes, so we should be retaining the raw data and not delete data during preparation of the data. No, I'm not deleting whatever. Data is sacrosanct. You're right. I'm not using it for the time being. When I'm saying I'm not using it, it is not that I'm deleting it or I'm purging it. It remains. It's only that I'm not taking it to the next level. I'm not taking it to the next stage, right? Yes. Is modeling the actual implementation of the business use case? Yes. All right. Absolutely correct. Business use case. Yeah. So the model that we build is going to help solve the problem that we started with, right? So it's actually solving the business. So business use case. So now you would know that I would have multiple different models for various different business challenges that I'm solving. So business would not just have the problem with sales numbers. It would have a problem in maintaining the right inventory levels, right? So what should be the MOQ? What should be the reorder level? What should be the time in which the orders need to be delivered, whether it is just in time or whether I stock, right? So all of those aspects uh, can be determined through a model, and this is where automation comes in place. Does data have a shelf life? Yes, it does. Depending on the business that you are in, depending on the market that you are in, depending on the product that you are working on, right? So a simple example: if I want to launch a product for the Gen Z, I would not need the uh, data of that particular product of the last 10 years. Probably last 2-3 years should be good enough for me, right? So that's how we need to look at it. Could you please help give one example of a model? We will get to it. I know it is sometimes a little overwhelming, but for the time being, I don't want to overwhelm you because overdose would lead to a lot of complications going forward. So for the time being, a model is like a mold, and we will talk about the model because this is an abstract concept as of now. We will make it real as we go forward. Do we have control on deciding the source of data? Yes, you do have. Uh, Control is basically the choice that you would make, right? So I would not want to bring in data from Instagram because my target audience is different. So for me, data that comes from LinkedIn is more important, more relevant, and to a large extent accurate when compared to that what comes to me from Instagram, for example, right? So I can decide. I may not have control of the data that gets generated on any of the various different sources, but I can definitely decide which source that I would want to use. Yeah, right. Okay. How will we split the data or validate the data? We'll get to it. Right. We'll get to it. When you say split the data, validate the data, are you referring to uh, are you referring to the sources of the data for splitting, or is it the data that I have cleaned up and then I would split it up for training? What is it that you're referring to? Okay. Evaluation phase. Oh, yeah. We'll get there. We'll get there. Right. So I will explain modeling now. Okay. So now that we have cleaned data, right? This is tidy data, and this is relevant data. This is accurate data. The data that doesn't have any anomalies, doesn't have any inconsistencies. It is clean data. It is tidy data, right? So now, if I apply some algorithm, right? I didn't use the word algorithm earlier. I used mathematical models, statistical models, which is nothing else but converted into an algorithm when we talk about data science. And what is an algorithm? An algorithm is a step-by-step instruction given to a machine, given to a system for executing it as per the instructions that is given by taking some input and giving some output. Basically, algorithm is nothing else but a program. Yes, absolutely. Okay, so let me tell you. Uh, I became really good at algorithms. I'm good at algorithms because it's a structured step-by-step way of giving instructions, right? So it brings with it a lot of logic that we need to build in, right? So when I was doing my MS from Bits Pilani, way back in 99, 2000, this one subject of algorithms, I flunked twice. Okay, so yeah, it was such a funny thing. I flunked twice, in spite of it being an open book. MS Bich Pilani, all exams are open book, but open book having any number of books actually doesn't help. It all needs to come from here, right? So I was good at logic all these days, but when I flunked in algorithm subject in third semester, it really put me down. I said, "Oh my goodness, algorithm is something, what some science which is beyond my comprehension." But then all these days, I was thinking that it is all about logic, and I was writing good programs and all of it. And all of a sudden, it put me down so much that it took me almost 6 months to get over it. And then, of course, I came out in flying colors. And today, I can safely say that it was a good experience for me. So the understanding of what an algorithm is very important, but not for you folks, because you don't have to build algorithms. Way back in 99, 2000, we didn't have ready-made algorithms. We didn't have ready-made programs. We didn't have ready-made functions. I'll get to functions later on. For folks who are not from the programming background, I will explain all of this later. But because we're talking about modeling, and I did mention about the word algorithm, I'm talking about this, right? So all of these algorithms are already inbuilt. They are already constructed in Python programming language, or even for that matter, R. So I already have access to a plethora of programs which are algorithms. The only thing that I need to know is what is the input that I need to give, and what are the parameters that needs to be tuned for this algorithm so that it gives me the right output, right? So things have become so easy today. Of course, it's like 25 years back to today. There needs to be some improvement, isn't it? Yes, there is a lot of improvement. But that doesn't mean you can't write your own algorithm. You can, if you want to, right? It doesn't mean you cannot write a function call which would make your life easy. Yes, you can, definitely. But for that, you would need to know a little bit more about software engineering and hardcore programming, which in today's world is also automated to a large extent. And you all being managers, I don't think you will need to get to the nitty-gritties of writing a code. You will, of course, need to know as to where and why the code may go wrong. And in specific cases of data science, wherein we are talking about machine learning algorithms, we would be enabling you with a lot of tips and tricks. We would be sharing a lot of these cheat sheets for you to refer to. And of course, during our interaction, there's a lot of discussion and debate, which would help you in knowing what could go wrong, and if it goes wrong, what needs to be done types. All right. So that's an algorithm now. And I have multiple such algorithms. I have thousands of algorithms available to me. These thousands of algorithms are used in Python programming language onto the data so that it will bring about an insight and provide you with some outputs. The output is where I will decipher as to what it means. And for that also, I would have a ready reckoner kind of kind of a construct that I would have, right? So evaluation phase, I'm going. Giving input is again a program. Giving input is again a program, or need to learn a program to convert into algorithm. Oh, no, 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 no. A set of instructions written as a program, and if it can be automated in the sense that it will take the input and then process it automatically and gives you that would constitute it as an algorithm. So for writing a program, you need to know programming, right? So that's the only thing. Don't get too worried or too hung up about it. You will explore how Python has made all of this easy, and I will explain all of that. Okay, so coming back to modeling, It's just that the data is available to me and I'm applying some program onto it, right? And this program uses the logic of some mathematical equation, some statistical equation, or a combination of mathematics and statistics coming together so that it will bring in a meaning to the entire exercise. And why is it so much of statistics here? Is because when we deal with data, it is statistics that will help me dig deep into the data. So all various different statistical concepts, statistical theorems, statistical concepts, concepts, theorems, and various different statistical equations get applied onto the data. So it could be Poisson's coefficient correlation, or it could be Jacquard's similarity, so on and so forth, right? These are just terminologies that I'm using. So build your vocabulary in the first place. So first 2 or 3 weeks is for us to get accustomed and acclimatized to the jargons and the wordings and the terminologies that you would need to know and understand. Right? So now that I've created this model, what is the evaluation that I'm doing? I'm evaluating whether the model is good enough for use. And what is the use? The model should be fit enough for solving the business problem that we started with. So, okay, now that I have a model, I will have to cross-check to whether it is solving the problem of the business from where I started from. So there are various different ways, methods, methodologies, guidelines, and frameworks available to us for evaluating the model, again, by using statistical ways and means. Right? So it all depends on the algorithm that you have used. Depending on the algorithm type, the modeling technique that we have applied, the evaluation would vary. So evaluation will tell me as to how accurate the model is in helping solve the business problem. In this case, how accurate it is in predicting what could happen in the future. For example, sales figures for a particular product. We've been doing it. We've been using Excel. We are doing some extrapolation, and we are getting fairly some predictions. I don't know whether the predictions would be accurate or not. I would get to know only after that quarter is over and I get the real numbers, right? So if I were to apply data science constructs and if I were to apply the modeling techniques here, I would get to know the accuracy of the model when I apply the evaluation of saying it is 92% accurate, which means to say that there is still 8% probability or 8% chance of you not achieving the target. Right? So this is how statistics, the science of probability, mathematics, and various different concepts, theorems, axioms, corollaries are all applied here. Now the question would come in, do I need to be good at mathematics? Do I need to be good at linear algebra? Do I need to be good at statistics, descriptive statistics, inferential statistics? Do I need to be good at it? Well, too late. Not that you cannot be good at it. You can definitely be good at it. Why did I say too late? Is because we are already into a job. We are already shaping up our career. So it doesn't make sense to basically get to the basics of all of it. But if there is a way wherein I can apply all of this, right? If I can apply all of this for solving business problems, that's good enough for me. And that's exactly what you're signed up for, isn't it? AI for managers. And you should know what to use when. How can be defined, but getting it done is something that you could rely on technical resources. You are interested, you can also be a technical resource. Nothing, no no hard and fast rule that you cannot pick up these newer skills. These are all skills that can be picked up at any given point in time, provided you have the wherewithal, provided you have the luxury of time, provided you have the luxury of uh, say the inclination towards it, right? So that's what it is all about. And now that I know that this model, right, this model is evaluated and satisfies the needs of the business to the extent of it being 95%, 96% accurate, business is good enough with that accuracy, I will deploy it in real time. Now, what is happening here, right? What is happening here is that the model is built on previous or existing data, right? It's what I know, right? So the model is built on existing data, whereas once it is deployed, it will use real-time data. So now again, this is an iterative process. The deployment is nothing else but continuous improvement and continuous deployment process, which helps refining my model even further. So it's iterative in nature. It is not sequential. It is iterative in nature, and it uses all the various different tools, techniques, and technology that we know of as of now, be it software programming, be it using software programming languages, be it understanding of the business, be it the project management, be it the functional understanding, be it the technical understanding, be it mathematics, be it statistics, be it anything, it'll all converge together, and that is what data science is all about. Right. I can see some questions. Though there can be a lot of algorithms available, but every business requirement drives the creation of new algorithms to meet the output required. Yes, I would need, depending on what the business need and the output required. Absolutely. So I could use a combination of algorithms, and probably I can build in my own logic, right? What is the margin of error acceptable industry-wide? Okay. If it is healthcare, healthcare, medicine, I would need 100% accuracy. 100%. If it is not 100%, I would not use it. I would not deploy it. Whereas, even in industries, depending on the severity of it, the criticality of it, it could vary anywhere between even 65-70% accuracy is good enough for a few trivial unimportant tasks, but generally anything above 85% should be good for any predictions to be used by the businesses, right? So when we say at least 85%, we need to achieve something near to 92% at least. With this process, it takes time, but yes, it is possible. It takes time. It's an iterative process, as I told you, and every time there is new data that comes in. To handle new data is always a challenge, because it comes from various different sources and sizes and shapes and forms and formats that we spoke about. So it's a challenge, but yes, we will get there. We will get there. It takes time. So you mean to say modeling and evaluation is a cycle of PDCA? Oh, wow. Okay. So you come from the operations management. Right. Okay. So plan, do, check, and analyze. Absolutely. DMIC, PDCA, all of this would definitely play a role. Yes. See, look at the correlation here. Wonderful. Absolutely. All right. Anything else? Yeah, get your doubts cleared. It really helps. Yes, bring in the correlation. It'll be good. Yeah, wonderful. Will the logic and model is always accurate and can satisfy the business requirements? Will the logic and model always accurate and can satisfy business requirements? It should, ideally, but it doesn't. because a programmer, a data engineer, a data analyst, a business analyst, and a data scientist can never understand the business as good as the folks who are running the business, right? So there is always the gap. But this learning process needs to be a collaborative and cooperative one. And only when that is done, right? Only when that happens, I will be able to build a good predictive model. And how do we evaluate the outcome and at what percentage of requirement is acceptable is all defined by the business, right? So we will evaluate the outcome of the model, right? So the outcome of the model is what I will evaluate by looking at minimizing the errors, right? So error in prediction. So what percentage is acceptable? Depending on the business needs, depending on the comfort of the business to have lesser accuracy or higher accuracy. Is it possible to get an accuracy of 97% from a forecasting model? Or after deployment we fail? What that means? We restart. Oh yes. Oh, this is common. This is common, right? So that's why I said we build the model, right? I'm building this model by using existing data, right? So existing data is something which I know, so I can learn, I can understand, I can what say I could play around with this data the way I want it, right? So it gives me that comfort feel because it is in a controlled environment. Now I can get to 97%, 99% accuracy, but it completely fails when you deploy it and new data comes in. When new data comes in, it completely fails, which means to say that probably the model that you have built will have to be relooked. And when I'm saying you need to relook at the model, it may be the way in which you have deployed the algorithms, the way in which you have fine-tuned the parameters, the hyperparameters will have to be looked into. We will get to what parameters are and what hyperparameters are later on. For the time being, all of these possibilities exist. And that is why the need for data engineers, data architects, data analysts, and data scientists is on the rise, right? Yeah, good. Okay. Is there any substitute of data in today's world? Substitute of data? Why would you want that? This is what is going to shape up the next 2-3 decades. All process requires ongoing improvement. Process, absolutely yes. For a business to reach this level, say predictive analytics, is digitization and digitalization mandatory? Is it possible for a bit immature business to leverage the models and achieve a good percentage accuracy? Yes, maybe if you may not have the data, but you may use the data of a similar business or a similar industry, similar sector, similar segment to build a better understanding. Yes. In terms of duration, how long this process takes from, oh, wow, okay. Again, it all depends on the sheer size of the data. We're dealing with big data, right? So when we say big data, these are not just the gigabytes. We are talking about terabytes and exabytes of data. So it would all depend on the size, the quality of the data, the characteristics of the data, the complexity of the business problem that we are looking at solving. So if it is a simple one with the use of big data, it would mean anywhere between 6 to 8 months, 6 to 9 months, depending on the team and the experience and the expertise that you have. Right. So there are a lot of these various different parameters, various different factors that one needs to look at. If it is a large project, large amount of data and complex business problems to solve, it would take anywhere between a year and a half to two before you bring about a good, reliable, and accurate predictive model. Business lean on speed these days. Yes. At what point do we find a balance between the acceptable accuracy of the data in a critical business domain and move ahead with actual production usage? Oh yeah, so it's a trade-off that we will have to bring in, right? So depending on the business, it is something I can live with 80%, 85% accuracy as well. But healthcare and medicine, I will never start really using it blindfolded if it is not 100%. Right? Yes. If the historical data has, say, 70% monthly and 30% yearly packs, but business scenario has changed and now 80% sold are yearly packs, does it impact the predictions of the models trained on the historical data? It will bring in all of these various different variations, right? That is exactly what needs to be understood, isn't it? So, if there are some changes that have happened, what could have led to the changes? And if this change exists, the trend continues, what is the business focus need to be on? Yeah, so that's exactly what it is all about. Is there any automated tool available in the market to assess and evaluate the requirement from the data which is collected? Tools available in the market to assess and evaluate the requirement from the data. No, there is nothing that is freely available, in the sense there is nothing that is a tool that is available. Generic tool is not there. This is something you will have to build, right? So that is something depends on the business, depends on the data sources, depends on the data type, right? So various dependencies. Should we, after deployment, come back to modeling to revalidate or get back to fetch data or both? Everything. You are fetching data any which ways. Because till now, you've been using the existing data for building the model. Once you deploy it, it is real data, real-time data. So you are actually getting data. So you don't have to go back to data. You're already into the data. We go back to the modeling. We go back to the modeling. We recalibrate it. Sometimes we'll have to recreate it, because I know exactly how the new data is behaving. Applying the Six Sigma levels based on the industry. Oh yeah, correct. All right. So while this is the process, there are a few jargons that we use. So OICMN is one way of looking at taking us through the various different processes for handling the data, right? So let me share this link for you to read through and enhance your understanding a little bit more. But I'm going to explain it any which ways, right? So obtain. What am I obtaining? I'm obtaining data from various different sources. Look at this. Gather data from relevant sources. When we say various different sources, these are relevant sources, right? And then the scrubbing. What am I scrubbing? I'm scrubbing the data. I'm cleaning up the data, right? So clean data to formats that machine understands, right? So I'll have to ensure that I clean up the data in a way that the machine can consume, the machine can understand. And after I've cleaned it, this is where I will start exploring. The machine will help me in exploring the data. So when I'm exploring the data, I find patterns, I find trends, I find the relationships, I find the correlations, I find the strength of the relationships. And how do I do that? By using statistical methods, right? So mean, median, mode, so on and so forth. Oh, link is not working. Okay, let me. Oops. Let me, which one did I share? The OICMN stuff, right? Wait a minute. Was this OICMN? Data Science Project Lifecycle, OICMN. I will share a different one, not to worry. OICMN, there you go. Oh, okay, good. Thanks, Abhishek. Is this working? Wonderful, good. Yeah, sometimes this happens, right? OICMN, wonderful. Good. Okay, so this helps. Okay, let me also change it in my presentation that yeah, many a times this happens. They would have just changed it, and there you go. Okay, so I generally refer the direct science, not the direct science, sorry. Yeah, so towards data science. Fine, good, thank you so much. Okay, so let me explain. Now that Now that I'm exploring the data. I'm identifying the patterns, I'm identifying the trends, I'm identifying the relationships. And this is what is going to help me in building the models. Now, here, construct models to predict and forecast, right? So, construct models. And how do I do this? By, again, applying statistical methods, algorithms. We will get to the details of all of this. And then put the results into good use. That is the interpretation in. So in is N. So that is the OSCMN model for us. So put the results to good use is for business use. And because we have dealt with so much of data, I could start using it for various other purposes as well, for not just creating good looking, wonderful dashboards, but for other business functions, other business units, other business users to also use it. Right? Okay, so turning data into insights and action, how does that happen? So current state inefficiencies are basically that I'm doing manual data stitching, right? I stitch it up manually. Uncorrelated data sets that come to me. So when all of this is there, it's a limited coverage. I have various different tools. They're all working in silos. So there are these limitations. Not that industries and companies and organizations and enterprises don't have data. Even today, they do have data, but the data doesn't talk to each other. For example, the data coming in from customer relationship management is not talking to the production planning control system. The data that is coming from the CRM doesn't talk to my supply chain management system, right? So they are all working in silos, right? So that is because they are driven by closed architecture. And there are different ways in which the data is being collected. The systems don't talk to each other. The architecture is closed. So there is no API interface. There's no interface in the first place. There is no interchange. So that's where there are a lot of limitations. Network data is cumbersome, closed architecture. It doesn't extend itself beyond, right? But then what I need is to bring in bring data from various different silos and consolidate it. So that is where time value of data is critical. So I need this data now. Only then I can convert data to information, to insight, to action. And as we go from bottom to top, the business benefits because it brings in better predictability. It brings in better understanding. And some use case, right? So from Boeing, this guy, Ted, you have to figure out how to really democratize data analytics capabilities. Within organizations, it's not easy. Of course, thanks to a lot of interventions that have happened of late, everyone has realized that data or the use of data, use of consolidated data is going to be a game changer, right? So only then, see what they say. That helps people to believe in it and to deliver solutions that don't require an extensive data scientist. Once I have all of this automated, I don't need data scientists. So what is the data analytics process? It starts with deployment. I've started with deployment. It's already deployed, right? What is deployed? Some model is deployed, right? So I need to understand the business understanding, data exploration, data preparation, data modeling, data evaluation, and deployment. So it is a continuous improvement, continuous management, continuous deployment process. So my ultimate deployment will need to be so good that it will provide me with the best output, the best results. Right? Make sense? Yes. So turning data into insights is a challenge in itself, and these challenges are bringing in the opportunities. So, what are the skill sets that one needs? Right. So we talk about business skills, we talk about technology skills, and we talk about analytics skills. So when we talk about technology skills, it's where the data engineers play a role, right? What do data engineers do? They basically, data engineers, they collect, collate, consolidate, structure, and help in analyzing data by using the right technical tools. Whereas business leaders and delivery managers are the ones who actually provide the business needs, the business understanding, so that the transformation can happen. And if you see the overlap between the business skills and the technology skills, is where data architects play a role, right? So they ensure quality, consistency to the present and future data flows, because data is flowing. Once I deploy the data is flowing, and while it is flowing, it needs to predict in real time. So that is where data analytics play a role. The overlap between the analytical skills and technical skills is where we talk about the data scientists. So analytical skills would mean that we have the workflow integrators and visual analysts. And then the overlap between technical skills and analytical skills is where data scientists play a role. So they develop statistical models. They use algorithms, they build these models, they evaluate the models, and keep improvising. So these are various different skill sets, overlapping skill sets when we talk about data science. And what you see as an overlap in between here is what is data science all about. And to get all of this in place, I need to have the right processes. I need to have the right methods. I need to have the right methodology. I need to have the right tools, techniques, and the use of technology in the right way. I need to look at the data in the right, in the best possible way, which aligns with the business needs, right? So there are various different parameters and factors and elements that one needs to focus on when we talk about data management, data science, leading to artificial intelligence solution creation. So here we talk about sweet spot of the best business skill, technology skills, and analytical skills is needed, because we need to build the data culture in the first place. As leaders, it's all on you to bring about this data culture. Only when I have this in place, all other processes will be helpful for me. All right. So again, from NBC Universal, it's not about the data itself. It's not just about the analytics. Look at it. Because in each of them, or rather, if I look at it in its silo, it's of no use, right? It's not just about analytics. Any more than taking a vitamin is not so you can claim you're successful to a pill every morning, right? So you need everything together. When it comes to analytics, we have to keep in mind the end goal is to make or help make better decisions more often. And that's exactly what businesses are for. And today, because of data, I can't go wrong, and I should not go wrong. All right. So we talk about digital native companies, we talk about e-commerce, we talk about quick commerce, we talk about various different online platforms, all of them, whether they are aggregators, whether they are platforms, platform-enabled businesses. These are all various different new models, new business models. Don't get confused with the predictive model. These are all new business models that are being built by existing business and new businesses. And this is why I was talking about innovation. All right. Yes. Okay. There's something on the chat that has come in. One major pain point is the data disconnect or lack of communication between systems. Absolutely. They don't talk to each other. Data silos. Right? Actionable insights. Absolutely true. What's the most efficient way to address this? Automation. Right? I will talk about it. Next week, we will get to the details of it. You just preempted. Would understanding the business and needs all has to come together. Everything has to work like a well-oiled machine. It's like cogs of the system, various different cogs coming together, which needs to be well-oiled, well-aligned, only then it will start functioning in a noiseless, impactful manner. Yes, so that's about it. How are we on time? Little extended, but that's okay, I suppose. So the usual customary thing that comes up at the end of every session, and here it is, the live session experience. 3 questions being asked, rate them in a scale of 1 to 5. And yes, I'm open to any questions, any thoughts, anything you would want me to touch base upon or make a note of bringing it up in our further discussions. Okay, no questions, all good?
So, Atul, I have a small question.
Yes,
Mantan
please.
here. So, uh, you mentioned the role of a data architect.
Yes.
So this may not be related to the curriculum, but out of curiosity, I see sometimes there would be confusions between data scientists and data architects.
Yeah.
So who essentially is a data architect, and what is their role in a scenario where we have a lot of data and statistics flowing into a model or a product?
Okay. So this is exactly what I'm going to cover next week when we talk about data engineering, right? So a data architect is the one who would, okay, let me refer back to the presentation, right? Let me share the presentation once again for clarity. Okay. So yes. So a data architect. So if you see here, quality and consistency of present and future data flows, right? So my present data flow goes from the various different sources and the ETL process. ETL is extract, transform, load. Then look at descriptive statistics, bringing in some correlation to it, right? And ensuring the quality of the data, which needs to be high, because beyond the point, I will start analyzing the data that is coming to me. Coming to me is now I'm a machine. A machine can analyze anything that you throw to it. The output or the outcome would depend on the quality of the data, because whatever data is given to me, I will analyze and give you the results. The outcome may not be as efficient or as accurate that you would want it to be, right? So that is the work of a data architect. A data architect works on ensuring that the right kind of data, which is tidy data, clean data, pre-processed data, is available for further processing, not just now, but for the data that comes in after the model has been deployed as well. Right? So that's how, that is what a data architect is all about. I'm going to go into the details of all of this, right? So good. Keep the questions coming. Yeah, thank you so much for all your encouraging words. This is just the beginning. We need to build it up one step at a time, right? So take your time in understanding all of this. Take your time in thinking through it, right? Ultimately, it's all logic. Ultimately, it's all common sense, right? Need more time to model all this info. Yeah, something that you will have to do. Sorry? Yes, anything? Somebody spoke?
Are there more materials we can read, or this is it?
Whatever is there on the LMS. So I think I should go. I've brought this up. So let me share it on the. Let me share it. Okay. So here. So what I would encourage you to do is don't use any of this for the time being. I will tell you when to go about. Okay. So first week video is what you should all go through, right? So it is available in the module and week 1, right? So, and there is a required quiz. So please ensure that you take it up. And if there is any difficulty, maybe you can skip it for the time being. For the first time, it's not that difficult. But if you think so, we can discuss it next week, right? And then the live sessions I was telling you, right? So the live sessions, this field. No, what I should do is I should bring it the student view. Okay, so the student view. Okay, so this is how you will look at. I've intentionally opened a previous instance, wherein this is how you will see, right? So when you open it up, this is what comes up, right? So you see the slides would be available to you here, and the recordings are the slides are given here, and the recording is uploaded here. So this is how you will see in the live session section.
Okay, and one last question. What's recommended to take the quiz after this session? Because material gets loaded on Thursday.
Yes. Correct.
Okay,
That'll bring in a different perspective, better understanding, right? So you can look through the questions, but don't attempt.
Okay.
Yeah.
Good one. Thank you.
So one last question, Atul, before we call
Yeah.
it.
Yeah.
So it's a good insight, right? This is for the first time I understood the obtain, scrub, explore, model, and interpret. So for all these things, it might be a futuristic question, but just for my understanding, do we need? Do we be using any tools for all these processes as such for the practice session, or how exactly it is?
We would be going through every step, every function through Python.
Oh, nice. Okay.
Yeah. Initially, there are a lot of examples that come through you through Excel exercises.
Yeah.
Right. So the intent here is not to make you an Excel expert, but the intent here is to impress upon you that you can use Excel as well for basic stuff. But I would not be dealing with small data. I would be dealing with huge amount of data wherein Excel would not be helpful. And that's where we will start looking at Python as it's not just a programming tool. It's not just a programming language. It's a one-stop shop for everything that I would do with data.
Great. Thanks so much. It was really helpful.
Wonderful. We'll keep discussing, right? And for all of you, don't think that whatever we discussed, you don't have to ask any questions going forward. You can ask questions. Even if we are in the 10th week, you can ask a question about week 1. Because probably at that point in time, you may have a eureka moment. Oh, okay. Please ask. Not